The math class. In this video, we will learn about commonly used static methods and static variables from the math class. The first static variable we'll learn about is math.pi. If you've taken geometry, you're familiar with this term. This variable represents the value of pi in geometry, or to put in more technical terms, the ratio of the circumference of a circle to its diameter. When I assign this variable to a local variable and print it out, I get 3.14 and change, as you can see, an approximation of the pi value. The next static variable, if you've taken calculus or are currently taking calculus, you might be familiar with this term, math.e, which represents Euler's number, the base of the natural logarithm. When I output this value to the screen, we get 2.71 and change. Again, an approximation of Euler's number. Math.pi and math.e are the only two static variables in the math class. Now let's discuss commonly used static methods from the math class. The first one being math.abs, known as the absolute value method. This returns the absolute value of x. Or in other words, if the parameter is already positive, then it returns the parameter. If the parameter is negative, then it'll return the positive value of that parameter. So when we output these four values to the screen, the absolute value of -5 is +5, the absolute value of 5 is 5, the absolute value of -2 is 2, and the absolute value of 2 is 2, so on and so forth. Next, we have math.pow, also known as the power method. It receives two parameters, x and y, and returns x raised to the power y. So our first call to the power method will produce 2 to the third power, which is 8. Then the next one, 5 to the second power, which is 25. Then 10 to the second power, which is 100. And then 10 to the fourth power, which is 10,000. Next, the math.max method, which receives two parameters and returns the greater out of those two values. So if x is greater, it'll return x. If y is greater, it'll return y. So our first call to max is going to return 5, since 5 is larger than 3. The second one returns 6, since 6 is larger than 0. The next one returns -3, since -3 is greater than -6. And the last call returns 3.02, because that number is larger than 3.01. Then, just as we have the max method, so also we have the minimum method, which returns the lesser of x and y. So when we output this program to the screen, we get 3, since 3 is lesser than 5. We get 0, since 0 is less than 6. We get -6, since -6 is lesser than -3. And we get 3.01, since that number is less than 3.02. Next, we have math.random, the random method. This method returns a random value between 0 inclusive and 1 exclusive. Now notice we called the random method 4 times in this program. Because it's producing a random number every single time, we're going to get a different number every single time, even though we're calling the same method. Henceforth, when we execute the program, we get something like this. We get 4 random values between 0 and 1. Now, it's worth noting that there is a way to manipulate the random method so as to make it produce a random value between any range. It could be 0 and 5, 0 and 10, between -10 and +10, -100 and +100, so on and so forth. There is a way to manipulate the random method so as you can manipulate the range of random numbers it can generate, but that'll be discussed in another video. Okay. Next, we have math.round, the round method, which rounds the parameter x to the nearest integer. Thus, when we execute this program, 2.013 rounds to 2, 2.499 rounds to 2, 2.501 rounds to 3, and 2.967 rounds to 3. Next, we have math.sqrt, which is the square root method. It returns the square root of the parameter x. Thus, when we execute this program, the square root of 4 is 2, the square root of 25 is 5, the square root of 100 is 10, and the square root of 10 is approximately 3.16 and change. Next, we have math.ceil, which is known as the ceiling method. It returns the smallest whole number that is greater than or equal to the parameter. or in other words, it rounds up. Thus, when we execute this program, 2.5 rounds up to 3, 3.84 rounds up to 4, 1.02 rounds up to 2, and negative 2.5 rounds up to negative 2. So, just as we have the ceiling method, so also we have the floor method. The floor method, which is the opposite of the ceiling method, returns the greatest whole number that is less than or equal to x. Or in simpler terms, it rounds down. Thus, when we execute this program, 2.93 rounds down to 2, 3.74 rounds down to 3, 1.47 rounds down to 1, and negative 3.39 rounds down to negative 4. The last method we're going to demonstrate is math.cos, which is known as the cosine method, which returns the cosine of x, where x is a radian angle. It represents a radian angle. Okay. For those who've taken geometry or are currently taking geometry, you're already familiar with the term cosine. If you have not yet learned about this term, no worries. The purpose of me showing you this is just so that you know that the method is here. So when I execute this program on these 4 values, this will be my output. Notice that for the second and fourth lines of output, I put the approximate symbol for approximately 0. That's because when you execute this actual program on your computer, you may not get exactly 0.0. Instead, you'll probably get an extremely small number, which pretty much means 0. But because of limitations of the hardware, we don't get 0. Instead, we get that extremely small number. But just know that it essentially means approximately 0. And that is our cosine method. It's also worth knowing that the math class also provides a sine method, a tangent method, and many other methods not mentioned in this video. If you'd like to view all of them, simply Google Java Math Class and you will find directories that list and describe each method in the math class. That being said, the methods you've seen in this video are the ones you will most commonly see used for this course.